Let's jump into level 2. And we'll just do it in the same little spot or in the same notebook as before. Basically, the difference between level 1 and level 2 is how much you're able to customize for this. Say you want to generate more than one image at a time. Say you want to display more than one image at a time. Say you'd like to generate something like Pokemon or animals or fantasy art, something that could confuse a safety checker. Because these models come from Hugging Face with a safety checker on them, as determined by the licensing. And I'm not telling you that you should always disable it, because it's there for a reason. You know, you don't want to use this model in a way that it shouldn't be used. If you're curious about that, we can go to Hugging Face and look for these models. Like here's the 1.4 stable diffusion model. When you come here the first time, if you're not logged in, it'll ask you to accept an agreement. And that agreement is basically what I was saying right here: direct use and misuse, malicious use, and out of scope use, where we don't want this to be generating demeaning, dehumanizing, or other harmful representations of people or their environments or anything like that. Please make sure that you're familiar with what is malicious misuse before you try anything crazy with this. This second portion that we're going to get into is a little bit more involved. We need PyTorch. And so let's go figure out how to install PyTorch. If you go to pytorch.org right here and hit install, it'll help you with this start locally. Now, if you're a little bit more advanced, you may be using Conda or libtorch or source. If you know what you're doing and you're confident you know what you're doing, I strongly encourage you to install this from source. But if not, installing from pip is not a bad option. And you just pick your OS. I'm on Windows, pick pip, pick Python, and then pick your compute platform. If you are not sure what your compute platform is, answer a couple of questions first. Number 1, does your computer have a graphics card in it? If you aren't sure, hit CPU. Don't mess with it. And then you just copy and paste this command in your terminal on here, which you can do, like I said before, you can do !pip and just paste what was there, or you can press Control-Shift tilde to open up your terminal in here and just copy and paste the command right there. Either way works fine. It's not a big deal. If you are interested in using a graphics card, let's go here, install NVIDIA CUDA. And it'll take you to this downloads page where you'll notice 11.8. Now 11.8 is not currently supported by PyTorch. So what you will want to do instead is find the number that works. So this site from NVIDIA is where you can see your compute compatibility. You'll want to come down here if you have a consumer NVIDIA graphics card. If you have an AMD graphics card, there is a way to hack this. I'm not going to show it in this video, but Google it. Other people have done it. You can do it as well. It's not that huge of a deal. NVIDIA GPUs, they come out of the box ready to work with this. So let's say you have that 3090, your compute compatibility is 8.6, which means that you should be more than good enough to download the CUDA toolkit for 11.6 right here. 11.6, you'd add that into your search and just download it from here. It would be really nice if anyone from NVIDIA watches this video, if you had a full list of releases so that you can just select them immediately, because you won't be able to run this unless you have both the correct PyTorch version and the correct CUDA version. This is why this is level 2. We're getting into intermediate stuff with our dependencies already. If you have an older GPU, I would recommend just going with the CUDA 10.2. You know, don't risk it. Don't risk getting something that your GPU can't handle. Or if you don't care, just do the CPU. Or if you don't know anything about this, use Google Colab or Kaggle or some sort of online GPU environment. And I can show you those real quick. colab.research.google.com. This is where you would make sure that you edit your notebook settings and make sure that you put a GPU as your hardware accelerator and hit save. And then you can run all of this code without having to deal with any local environment. but they'll let you run it exactly as is. It's a notebook. You can just copy and paste. It's not that big a deal. Once you have the correct command, go ahead and copy this. If you're on Windows, you may run into problems with this pip3. It's the same as pip, just delete the 3 and the command should run. If it doesn't run and there are errors, read the error, Google it. I guarantee you're not the first person to come across that error, and there is an answer out there. Let's get into the actual level 2 code. So we want to from torch import autocast. This is going to help us run things. And then from PIL, this is pillow that we downloaded earlier, import image and image draw. We're going to run this. Now we have these imported. Next, we're going to create functions. If this is your first time programming, just copy and paste. If this is not, this should give you some basic functions that allow you to extend them and do whatever you'd like. First, we're going to have a function that's going to wrap around the current safety checker for the Stable Diffusion pipeline and essentially just pass nothing instead. We're going to call it dummy. So def dummy. And it's going to take images, and it's going to take star KWARGS, quargs, our keyword arguments. And we're going to return images and false. And that's it. Our second one is, this is going to help us to generate multiple images and display them in here. Instead of having to save them every time, you can just save the ones that you like. That's just an image grid. And that's going to take images and rows and columns. And that'll look like this. So assert length of images, because it's going to pass a list, is the same as rows times columns. We do not want too many. Width and height equals the first image dot size. Grid equals image dot new, and it's going to be RGB encoded. And the size of that image is going to equal, and we're going to do some quick math, columns times width, rows times height. And then grid width and grid height equal grid dot size. And then this last part is actually putting the image into the grid and drawing it. So for I image in enumerate, this keyword allows us to return both an index number and the original list that we're enumerating. Images, grid dot paste, image box equals, and this is going to be a little bit more complex, but we're going to get the remainder of I divided by columns times width, and we're going to get I rounded division columns times height, and then we're going to return grid. Now we're going to actually change the safety checker, and we're going to generate a grid with a prompt. It's going to be pretty great. So pipe.safety checker equals dummy. Number of images. This can be whatever you want. I would recommend looking at your GPU and how much VRAM you have. Every image should take probably 2-ish gigabytes with the current Stable Diffusion pipeline. If you're not sure, don't do too many. I wouldn't go above like maybe between 4 to 6. If you're on like a 3090 or a 3080, if you have lower than 12 gigabytes of VRAM, maybe 2 or 3 is what you need. But this allows you to create a grid and display it in line. So number of images, for me, I'm just going to do 3 so you can see it. I'll do 4 so we can see it. And the prompt going to equal, we're going to do brackets, and I'm just going to copy and paste this right in our prompts, and I'm going to add right at the beginning masterpiece and best quality. These are two things that some of the big names in this image generation industry do as kind of a hack to get really good stuff in the beginning. I think Novel AI does this, and probably Midjourney as well. If you want images that look like theirs, that's something to add to the beginning. And then we're going to multiply this list by the number of images that we just set before. So what this translates to is a list that says the same thing several times. If you want to do different prompts, all you would do is add a comma at the end of this and add another prompt after it, and make sure to delete the number of images. You don't need this if you're going to do all different prompts for your images. You only need this and this if you want to do the same prompt for 4 images and just see the different stuff that comes out. That's why we're doing that. So with AutoCast, to help manage our memory and our devices, and inside here we're going to do CUDA, unless if your PyTorch installation is CPU, then do CPU. Or if you don't want this to run on your GPU, then put CPU in these quotations instead of CUDA. Images equal pipe prompt num inference steps equal 28. If you remember up here, this is a 51. This is the default. I'm shortening it. I only want 28 inference steps instead of 50. Images. And then image grid. We're going to pass images. Rows equal 2 and columns equal 2. These variables, you have to do a little bit of math for your number of images, right? If you want to generate 3 images, for example, you want probably 2 rows, 2 columns, and it will just do 3 and you'll have an empty box. If you want 6 images, you want probably 2 rows and 3 columns, or 3 columns, or three rows and 2 columns. You just got to do a teensy bit of math to figure out how you actually want to display these. But once you're ready, and again, this is a quick little shortcut for navigating around these Jupyter notebooks. Shift Enter runs stuff. You don't if you don't want to press Shift Enter, that's how I've been running this without clicking the little play button up here. If you want to run any cell, just hit the play button or select inside the cell and hit Shift Enter, and it'll run it. Okay, here we are at the end of that generation. If you ran the code exactly as it was, you probably got an error that IMG was referenced before it was assigned. This is because up here it just had IMG. That needs to have the S on it, and then you can run right through it. If you're interested in getting the code in a pristine condition after I've already written it all instead of following along with me, you can go here, NLP, transformers, stable diffusion, and stable diffusion in 5 difficulties. You can look at this and you can even skip ahead if you'd like, but you can see we've got the same thing here and here. So if you run into images with these functions, you can come and just copy and paste what you see here. But once that's finished running, this is the output on my computer. It looks really good. That looks a lot like a masterpiece by Van Gogh of abstract planets in space. There we go. If you want to save any of these, this images portion is still in memory. You can check that by looking at the variables. Right here, images is a list. Right, and you can see all of these images, and you can see the objects that they are right now. So if you like any of these, this is image 0, 1, 2, 3. All you would do is do images. Let's say you really liked, let's see, what's my favorite one? Probably this 4 and this 2. So I'd do images 1 real quick, dot save, da-dum. And it's the same thing as before, images, and I'm gonna call it planets Van Gogh .png. And then we are gonna do, hold on, actually, we can't run this in the exact same cell, otherwise it's gonna run everything before it. So I'm actually gonna make a new cell right here, where I'm gonna do both of these. And we're gonna do image 3 as well. So again, 0, 1, 2, 3. It starts at 0. And we're going to call this 1. And then we can save both of those, and then they appear right in here. And you can see this is one that I generated earlier. There's image 2, there's image 3. You don't have to save them in this grid. You can save it in the grid as well, though, if you'd like. All you would do is take this, you'd say grid equals this, and then you'd save it in exactly the same way, just pil.save.